May I open today's review with a double thank you. Subscribers, thank you. Viewers who choose to subscribe, thank you. This is Mr. Richards Teaches, bringing you your Math 3 Unit 5 quiz review in his robotic voice. Kicking it off with number 1, determine the asymptote and y-intercept of the exponential function. And part 1 in red, asymptote is the constant after the exponent. Well, our exponent is raised up with that x plus 3, and yes, I did hear it correctly. Our asymptote is simply just 5. Go ahead and circle. I will erase that because we will switch to blue for step 2 per the usual. And step 2 is just simply asking us to set x equal to 0 and calculate to find the y-intercept. So let's zoom in tight here. I am going to highlight our little x there. That's going to be set equal to 0. I will write the entirety of it in blue. 3, open, 2, close, 0 plus 3 as our exponent plus 5. Let's go ahead and put that into our calculator. 3, open parenthesis, 2, close. We are going to use that little up above division there, that arrow, and then we will just enter 0 plus 3. Don't forget we need to right key arrow over, so we're out of exponential land. Hit plus 5, go ahead and yes, click enter. What do we get? 29. So the y-intercept, well, is simply 0. 29. Go ahead and circle your answer. If you'd like to try the practice at home, please go ahead and pause the video before we move forward to number 2. And onward to number 2. Write the exponential equation in logarithmic form. Step 1, exponential base and log base are the same, so let's keep that in mind. And our exponential base here is just simply 3. So when we convert this to a logarithmic function, or in form, let's do log, base 3. All right, step 2, exponent becomes total, and total becomes base of. All right, so we will do this just in blue. Our 4 and our 81 are simply just going to kind of flip-flop here in a sense. So it will be the log base of 3 of 81. Bring down our equals. Set the 4 down. Go ahead and circle your answer. But before we move forward, we do have our practice to pause. Moving forward to number 3, write the logarithmic equation in exponential form. Log base x of 128 equals 7. And yes, step 1 in red. Log base is the same as exponential base. Well, let's read it one more time. Log base x of 128. Well, log base x. Let's go ahead and put it down. And let's look to step 2 in blue. Base of becomes total, and total becomes exponent. All right, let's zoom in again. Log base x of 128 becomes our total, and 7 becomes our exponent, meaning again we're simply flipping. So it's x to the 7th equals 128. Go ahead and circle your answer. And for your practice problem, please feel free to pause. To number 4 we go. Trucking on to number 4. Evaluate the logarithm. We are simply just going to enter in the calculator, but you may want to jot this down. We are going to hit math, followed by alpha, and then back to math before we enter in the function. Math, alpha, math. Oh my goodness, look, log base 4, right key arrow over of 256. Hit enter. We do get 4. Feel free to pause the video and try your practice. And roaming on to number 5, determine the inverse function of y equals log base 3 of x minus 5 plus 6. Step 1, swap x and y. First, let's identify our x and our y, and let's simply swap them. X equals log base 3 of, yes, it will be y minus 5 plus 6. Great call. Zoom out for step 2. Isolate the log expression. Our log expression is log base 3 of y minus 5, hanging out on the same side as plus 6. What do we need to do? Yes, subtract 6, not just from one side, but from both sides. Wonderful job, all my viewers. Thank you. X minus 6 equals log base 3 of y minus 5. Let's go ahead and cancel that out with the 6 minus 6. Step 3, rewrite an exponential form. All right, so to make this left side and set it equal to our right side, we need to rewrite this as an exponent or exponential form. We will use that same base of 3, and the x minus 6 becomes our exponential, equals, well, now we can get rid of the log base 3, pull down our y minus 5 because these two are now equal. And then for our last step in 4, we just need to solve for y. Well, what's hanging out on the same side as y? Yes, it's minus 5, and what shall we do? We will add 5 not just to one side, but to both sides, and just simply write our answer as 3 to the x minus 6 plus 5 equals y. Go ahead and circle your answer. Now, if you'd like to try the practice, please pause the video and do so. Rolling on to number 6, condense the logarithmic expression 4 times log base 7 of x minus 2 times log base 7 of y plus 1/5 times log base 7 of z. Step 1 in red, apply power property where we can. All right, all of our multipliers, our 4, our 2, and our 1/5, we are simply going to apply the power property. All right, so let's just rewrite those out and let's see what those look like. Yes, we will write it as log base 7 of x to the 4th power. Bring down our minus there. Log base 7 of y to the 2nd plus log base 7. Ooh, what do we do with that fraction? Well, we'll take the 5th root of z. All right, so for moving on to step 2 in blue, product property for addition. All right, so we're going to be looking at the two positive terms because it says addition. All right, so let's go ahead and boom and boom. Let's take a look at those two. All right, what do they both share in common that we can condense? Yes, they both share that log base of 7. So let's go ahead and write that log base of 7 multiplied by that x to the 4th, and right by its side, since addition becomes multiplication. Wonderful. That 5th root of z. All right, we will just continue to write out minus log base 7, y to the 2nd, move forward to our 3rd step, quotient property for subtraction. Let's combine what these two have in common here. That log base of 7, not combine, but find. And when we're working with subtraction, what does that convert into? Yes, division. So let's just make that a little division, and division tells us there will be a fraction. Let's go ahead and write that log base of 7. Well, up top will simply be x to the 4th multiplied again by that 5th root of z. And we will just simply set that over y squared. Go ahead and circle your answer as it is now condensed. Please pause the video to try your practice. Thank you. Accelerating on to number 7, solve the logarithmic equation log base 4 of 7x minus 5 equals log base 4 of 3x plus 11. Step 1 in red. We do have the equality property, and we can eliminate the base and set binomials equal. Why? Because take a look at that log base 4, log base 4. We've got it simple, as yes, we have equality. And we will just simply rewrite this as 7x minus 5, set that equal to 3x plus 11. Step 2 in blue, solve for x. By now, we do not use colors for each step when solving, so let's just go ahead and boom, subtract 3x from both sides. 7x minus 3x gives us 4x. Bring down our minus 5. Bring down the equals. 3x minus 3x is the big cancellation. Bring down your 11. Next step, 4x minus 5 equals 11. We need to get that 4x by itself. We will add 5 to both sides. Continue to bring things down. Our 4x just comes down. Negative 5 plus 5 is our cancellation. Bring down our equals. 11 plus 5 is the sweet. Yes, 16. Divide each side by 4. And x equals 16 divided by 4, which is, circle your answer at 4. Thank you. But please go ahead and pause the video and jot down your practice. Graduating on to number 8, solve the exponential equation. 3 to the power of x plus 2 equals 243. Step 1, rewrite 243 as a base 3 to the power of. Why is it to the base 3, I wonder? Oh, okay, we have a base 3. Wonderful. So let's just do this. We're going to write our base of 3. And then we're like, oh, what's it going to equal to get to 243? Well, let's just try 3 to the power of 5. Ooh, it works. 3 to the 5th power. So if you're stuck on your practice, use your calculator. And then I'm just going to copy down this 3 to the power of x plus 2, bring down our equals, and move on to step 2. Equality property, eliminate base and set exponents equal. Oh my goodness, an exponential with the base of 3 and an exponential with the base of 3. We can go ahead and eliminate those and just rewrite this as x plus 2 equals 5. Step 3 in green, solve for x. Whoa, what's hanging out with x? Yes, it's plus 2. We will subtract 2 from both sides. Do a little computation here, and x equals 3. I didn't like the placement of that equals. All right, go ahead and feel free to pause the video and try your practice. Cooking on to number 9. Solve the logarithmic equation. Log base 3 of 2x minus 1 plus 2 equals 5. Step 1, isolate the log. Log base 3 of 2x minus 1 is hanging out with that plus 2. How do we get rid of it? Yes, we will subtract 2, not just from one side, but from exactly both sides. Log base 3 of 2x minus 1 equals 3. Wonderful. Step 2 in blue. Write right side as exponential for equality. Oh, I see why. Because we have a log here, and we know that exponentials share the same base as the log. So let's just go ahead and rewrite that as 3 to the 3rd power, because our base is 3. The 3 becomes now the power. Let's go ahead and get rid of that as it's now equal to it. Bring down our 2x minus 1. Set that equal. Step 3 in green, we need to calculate the exponential. Before we do so, let's just jot down 2x minus 1. 3 to the 3rd power. Yes, great work. 1927 Yankees. And step 4 in orange is simply to solve for x. What's hanging out with 2x? Yes, it's a minus 1. So what do? We simply just add 1 to both sides. Do a little computation. And 27 plus 1 equals 28. What are we dividing by? Yes, great job. It is the 2 giving us x equals 14. Go ahead and circle your answer, and at this time, zoom out, pause the video so you can practice yours. Brewing up number 10, solve the exponential equation 2 to the power of 3x plus 5 equals 41. Ooh, 6-stepper. Step 1, isolate the exponential. Let's zoom on in. Well, our exponent is 3x, so we need to get 2 to the power of 3x by itself. We will subtract 5 from. Wonderful. Both sides. Go ahead and bring down that 2 to the 3x, give out a cancel, bring down your equals. 41 minus 5 is simply just 36. Step 2, natural logarithm to both sides. Okay, wonderful, not bad. Let's just go ahead and rewrite that. ln for our natural log, 2 to the 3x enclose equals the natural log of 36. Step 3 in green, we will use the power rule. Oh, wondering what I was going to do with that this entirety. No big deal. We'll just simply drop it in front. Rewrite that as 3x. Bring down our natural log. And just put the 2 on the inside now that that's gone. And set it equal to the natural log again of 36. Not so bad so far. Step 4 in orange. Let's isolate that 3x. Well, it's being multiplied to the natural log of 2. So what do we need to do? I was trying to do my best Chris Farley impression there with the do. But I don't know if it was really working. All right, so let's go ahead and cancel that off. That isolates that 3x. We will set that equal to the natural log of 36 over the natural log of 2. We need to calculate the natural logs. All right, so what we can do is we can truly just do this in the calculator. Yes, exactly what we'll do. We will hit the natural log, that ln right there. We will type in 36, hit enter. Then we will hit divide because we have our fraction. And we'll divide that by the natural log of 2. So again, hit that ln, type in our 2, hit enter. What do we get? 5.1699. We'll stop right there. So 3x is kind of similar to 5.1699. And our sixth and final step is to divide by the coefficient of x, just like when solving. Let's divide each by 3. Let's bring down our x, and our x is similar to, well, let's just hit divided by 3, 1.7233, or if we did our 5.1699 divided by 3, we get 1.7233. Go ahead and circle your answer. Now, if you'd like, please pause the video, jot down your practice. Waiting in turn patiently is number 11. Find the extraneous solution to the logarithmic equation log base 6 of x plus 5 plus log base 6 of x equals 2. Step 1 is the product rule. All right, so let's take a look. When we see that addition, we know that it's going to turn into multiplication. And what do those first two terms share? They do, that log base 6. Let's go ahead and write that out. Log base 6, x plus 5. Ooh, we'll be multiplying, so let's just go ahead and bring down our x as they share that log base 6 equals 2. Step 2 in blue, write 2 in exponential form. All right, so this is where we will take a look at our log base of 6 right there. And we will put this 2 into exponential on the right side. They share the same base, so it'll be 6 squared, or 6 to the second power. This will permit us to get rid of our log base. So let's just go ahead and rewrite this side real quick. Step 3, we will simplify the left side, or x plus 5 and x, and then we will calculate the exponential. No big deal. All right, so x times x gives us, yes, x squared, 5 times x gives us wonderful 5x. Bring down our equals, and 6 squared is just 36. Moving on to step 4, subtract 36 from both sides to set quadratic equal to 0. All right, so let's go ahead and take a look at that. Minus 36 minus 36. Bring down the x squared plus 5x minus 36 now equals 0. We will need to factor the quadratic. All right, so we're looking for two numbers that when multiplied get us to negative 36 and when combined get us to a positive 5. All right, so we will use x plus 9 and x minus 4. We'll set those equal to 0. 9 times negative 4 gives us our negative 36, and 9 minus 4, yes, gives us our 5. And then we need to set the factors equal to 0. Well, just by doing so, let's actually take a look at it. We'll set them both equal to 0. X plus 9 equals 0. X minus 4 equals 0. We will solve for x for both of these. X equals negative 9. And let's take a look over here. We will add 4 to both sides. X equals 4. Looks a little sloppy, but the extraneous solution for this one, because if we plug in a negative 9 for x, well, let's just take a look. Negative 9 plus 5 equals negative 4. And if it's not above 0, it's extraneous, making negative 9 our extraneous solution. Please feel free to jot down number 11 to practice. Forthcoming is number 12. A population of 1,200 dragons decreases at an annual rate of 8%. Write an equation and estimate the population in 5 years. Decreases, that tells us we will be using exponential decay, hence the subtraction. Let's just highlight a few things and plug in to solve for our P of t. And let's zoom on in. All right, our initial population of 1,200 dragons, well, our initial pop right there is 1,200, so we're just going to write that out. We will open a parenthesis. The formula calls for the 1. We do know that it decreases, hence the exponential decay. If it were growth, we would use a plus. If it were increasing, at an annual rate of 8%, well, that 8% when written is just simply 0.08. Let's close that parenthesis. And then for how many years did it say? 5 years. That represents our t, our time. I was actually going to write the t, but let's just put the 5 and enter this into our calculator. 1,200, open parenthesis, 1 minus 0.08, close parenthesis, up 5, enter, 790. Go ahead and circle your answer. I will zoom out so you can take a look at your word problem, highlight a couple of things, and go over that in the answer key. Incoming is number 13. You invest $1,500 at an annual rate of 5%, compounded continuously. About how long will it take for the investment to grow to $2,500? Well, our $2,500, we are going to use that to represent our A. So let's go ahead and write that 2,500 because we are step 1 writing the equation. Let's set that equal to our principal. Well, if we invest $1,500, well, that's our principal. That's our initial investment. And we're going to multiply that times E. Remember, that's at 2.71 to the rate times T. Well, our rate is 0.05. So let's go ahead and put in 0.05. And then we will put in a t because it doesn't say, it's asking how long it will take. So we're actually solving for time this time. Yes, we're done with step 1. Step 2, isolate the exponential and reduce fraction. All right, to isolate this exponential, yes, it's being multiplied. So what do we need to do? Divide each side by 1,500. Now, when we reduce this, our greatest common factor is 500. 2,500 divided by 500 is simply 5. 1,500 divided by 500 is 3. Equals, and we will just copy down our e to the 0.05 times t, in which we are solving for. Step 3. Equality rule of natural log and e. All right, so in order to get rid of that e, we need to take the natural log of 5 over 3. This allows us to cancel out our e and bring down our 0.05 t. Divide both sides of rate, or by the rate here. Our rate, we're looking at that t by itself, is 0.05. And we'll also divide that by 0.05. We need to go to the calculator. Let's go ahead and put in our natural log of ln. So there it is again. We will do 5 divided by 3. Do me a favor, hit enter. Divide that by 0.05. Hit enter again. What do we get? 10.21. We can't go up. We're only looking for years. 10 equals our time. Go ahead and circle your answer. And feel free to jot down your practice problem right here. Free falling onward to number 14, sketch and graph the function y equals log base 2 of x plus 3 minus 4 and state the asymptote, shift, reference point, domain, and range. Well, the asymptote is simply x equals the opposite of the inside number. All right, so we're just going to put x equals, what's inside the parentheses? A plus 3 or a positive 3, so we will just make that yes, negative 3. Our shift is simply opposite the inside number, and outside number stays the same. All right, so we already did opposite the inside number, which will give us a negative 3. The outside number stays the exact same at negative 4, but it also just wants the directional sense of it. Well, it's going to go to the left 3 and down 4. Basic, since we've been doing for a long time. All right. Reference point is opposite the inside number, plus 1. Outside number stays the same. Let's just go ahead and write it out. Opposite the inside number will be negative 3 plus 1. Put in the comma. Outside number stays the same, which is simply, yes, negative 4. Close that up. Do some basic computation to get our reference point. Negative 3 plus 1 is negative 2. And again, that outside number stays the same at negative 4. All right, our domain is opposite the inside number followed by infinity. So again, that's just going to be negative 3 followed by infinity. Our range I'm not even going to write out because it's going to be negative infinity, infinity, and then we will just graph a couple of things. X equals negative 3. That will be our asymptote. I will highlight that in pink right there, and our negative 3. Let's go ahead along our x-axis, find negative 3, and go ahead and just draw a little straight line. I know it's going to be dashed. I should have told you to do dash. Let me do partial so it looks good. Or you can just do this and erase it if you'd like. There we go. Looks a little better. All right, then we will plot our reference point. We will do that in orange here. All right, so we're just going to go to negative 2 and negative 4 and plot a point. So 2 to the left, 4 down. We already did the shift. Yes, we will plot our point. Wonderful. Our domain here, opposite inside number of -3 infinity. Well, let's just go ahead and we will, just like Miss O taught us, hug the line tight and up into the right. Go ahead and complete your graph. And if you would like, please pause the video. All right, you have number 14 awaiting. Everyone in order now. It's number 15. We will be expanding the logarithm log base 6 of 8x to the 5th over y cubed. Step 1, apply the quotient rule. All right, when working with division, this will turn into, yes, subtraction. And since we are expanding, well, everything shares that log base of 6. So let's just go ahead and highlight that for us. And then we will do the log base of 6. 8 times x to the 5th minus log base 6th y cubed. Step 1, done. Step 2, apply the product rule to expand the first term. Oh, when things are being multiplied, log base 6 of 8 times x to the 5th. So we need to break that up. So let's go ahead and write that log base 6. I don't know if it's a breakup or just simply an expansion to the 8th plus log base 6 x to the 5th. Go ahead and rewrite your minus log base 6 y to the 3rd power. And for step 3, we will apply the power rule. So anything here, ooh, x to the 5th power, y to the 3rd. All right, so let's go ahead and do that, please. Thank you. We will just simply copy down our log base 6 to the 8 plus, oh, that 5 goes in front, log base 6x minus that 3 again goes in front, log base 6y. Go ahead and circle your expanded logarithm. But please feel free to pause the video and try 15. After 15 is finally the grand finale of 16. Solve the logarithmic equation. Log base 4 of 2 plus log base 4 of 6 minus x squared equals 1. Step 1, we will convert 1 to an exponential and eliminate logs due to equality rule. Yes, we're just going to simply do that in one step this time. All right, we should be becoming a little bit more comfortable with this. When we're adding, yes, it means to multiply. And with our log base of 4, we can rewrite this 1 as an exponential of, yes, it needs to have the same base, 4 to the 1st. Let's go ahead and get rid of our log base 4s and simply just rewrite our left side as 2 times 6 minus x squared equals 4 to the 1st. Yes, step 2, simplify left side and calculate right side. Zoom on in. 2 times 6 is, yes, 12. 2 times x squared times negative x squared is negative 2x squared equals 4 to the 1st is simply just 4. Isolate term with the variable in green. What's hanging out with negative 2x squared? Yes, it's positive 12. We will subtract 12 from both sides. Bring down your negative 2x squared equals negative 8. Step 4 in orange tells us to divide by the coefficient of the variable. All right, so we'll divide each side by negative 2. That will give us x squared equals a positive 4. And for our 5th and final step, square root both sides to get x by itself. And when working with that root, x equals plus minus 2. And that is a wrap. Unless you want to try that practice for 16, pause the video. Following next is your answer key. And for your practice answer key, asymptote of y equals 8, y-intercept of 0, 20 for number 1. For number 2, log base 2 of 32 equals 5 when you rewrite that exponential as a log. For number 3, we had to write the log as an exponential. It will be x to the 4th equals 81. For number 4, you just had to type in, evaluate the logarithm. Well, it's just 3. For number 5, all right, you had to determine the inverse function. Your answer is 4 to the x minus 8 plus 2 equals your y. For number 6, you had to condense the logarithmic expression, giving you log base 3 of x squared y over cubed root of z. For number 7, you had to solve the logarithmic equation, x equals 6. For number 8, you had to solve the exponential equation, x equals 1. For number 9, you had to solve the logarithmic equation, x equals 12 over 5, just leave the fraction. For number 10, you had to solve the exponential equation. X is similar to 1.3219. For number 11, we defined the extraneous solution. So when we plugged in x equals -8, well, -8 plus 5 gives us -3. And we need an answer above 0, so that's not going to work, giving us our extraneous solution of x equals -8. For number 12, plug and chug into the formula, 569. For number 13, again, plug and chug into the formula, 25 equals your t of time. For 14, for your practice, should have had an asymptote of x equals 6, a shift of right 6 up 3, a reference point of 7, 3, a domain of 6, infinity, and a range of -infinity, infinity. We will hug our asymptote and go up to the right, and that is your graph. For 15, we had to expand the logarithm. You should add log base 7 of 5 plus 4 times log base 7 of x minus 2 times log base 7 of y. And for 16, solve the logarithmic equation, x equals plus minus 3, because we took the root, and that is a wrap.